Hello, Julieta. That's a pretty name. My name is Lisa, and I don't think I've worked with you before. How this works is that you send me questions like you did, and I make you a short video to try to explain it. And then that can be a starting point. So if I sort of am interpreting your question correctly and I answer it right the first time and give you all the information you need, then that's great. If not, you can always write me back and say, yeah, but you didn't explain this, and I'll make you another video and we'll keep going, okay? So what I have here is the first table that you were given. There's, I think, 4 on your sheet, but they all look quite similar to me. And you're saying that you're being asked to interpret the t-test, but you're not sure what to do. Not sure how much background, and that's one thing where we do the online appointments where it's a little more difficult, because if I was sitting across from you, I could just ask you. But I'm not sure how much background you have in terms of the t-tests and z-tests in terms of interpreting them. The idea is just really quickly that we have our sort of, whoops, I ran out of space there, our normal curve where the middle of the curve represents our mean value. And then on either side of that, we move out by divisions called standard deviations from the mean. And that by the time that we get out to 2 standard deviations approximately, we have actually gone about 95% of the way through our data. So at minus 2 standard deviations and positive 2 standard deviations there, then 95% of our population is what we're looking at there, which means that on this part of the curve here and this part of the curve here, which should be equal, but I ran on into the side of the screen there, that's where the other 5% live. And so on a two-tailed test, you should have 2.5% of the population in this part of the curve, and then the other 2.5 in this part on the right. And those guys are the extreme values. Those guys are the ones that are completely different than everybody else, or let's call it significantly different than everybody else, because we're going to consider this area to be our normal population. 95% of whatever it is we're testing fits into our normal population. The other 5%, they are in an abnormal group. They are in what we call the critical region of this curve because they differ significantly than the rest. So a t-test, a z-test, both of those are really testing whether you live in the 95% in the blue region or whether you're in the green. And that's what our hypothesis test is all about. When we say in our null hypothesis that one mean equals another, we don't really mean equals like we did in other subjects in math in school. We mean that they are both in the blue region. They're both in the normal region. That's what makes them equal in statistics. If they're not equal, if that's your alternate hypothesis, that those two things are not equal, that just means they live in the green region on your graph. They're in that extreme area of the 5%, if it's one-tailed, or 2%, 2.5% on either side if it's two-tailed. And that's all we're testing, okay? So if we go back and we look at the data that you're given for our t-test, luckily they've done all the calculations for us, so we just have to interpret it. It looks to me, looking at this line, that what they're saying is that this is a two-tailed test. I hope you can see that color. The reason I'm thinking that is that it just said we're testing whether they're equal or not when they say hypothesized mean difference. They're just saying it's either equal or it's not. And in this case, when they say there's no difference, they're saying it's equal. So I'm assuming it's a two-tailed test, and it doesn't matter if one is higher or lower than the other. So we're going to go with that assumption. You might have more information somewhere with your assignment that explains something more, but I don't see anything here that leads me to believe otherwise, okay? So with all the information that we are given, the important things that we're looking for here are a crit value, and I think because we've decided that it's going to be two-tailed, then I have a t-crit given, and the t-crit is 1.98. So the really important thing now is to get something to compare that to, and I'm gonna look for the t-stat, which I conveniently drew my red line right through, but here is your sorry, I didn't draw my line right through it. Here's your t-stat, and so that's the value that you would get if you did all the calculations to find the t-value from this data. So now that we have those two values, we're going to compare them and try to either accept the null, which says that those are basically equal, or reject the null, which says that they're quite a bit significantly different. So t-crit of 1.98, that means that my t-crit line is over here, I hope you can see that, to the right of my two standard deviations. My t-stat is 1.37. That means that here's one standard deviation. It's just a little bit further than that along between 1 and 2 standard deviations. And so here's my 1.37. So as we can see, the t-crit line is 1.97. The t-stat is 1.37. It's a smaller value than the t-crit, which puts it in the normal region. Therefore, we would fail to reject our null hypothesis. Okay, so that's a conclusion that we're going to make based on where those two lines are. If your t-stat, or test statistic, is to the left of your t-crit, then you reject, or you fail to reject your null. Your conclusion is that basically it's in with that big happy family of 95% people who all consider themselves equal. Okay? The other information that you've been given here that we need to take a look at is down at the bottom. They give you some more data or some more conclusions. Small effect size of 0.254 and confidence interval of 0.249 to 1.389. So what they're saying there, the effect size to begin with, it tells you whether or not the difference between the two groups average is large enough to have a practical meaning. Your effect size here is small. Anything from about 0 to 0.2 is considered a small effect size. So your effect size is small. So that means that the difference between the values that you're testing does not have that much meaning. In other words, you're supporting your conclusion to accept the null hypothesis that things are pretty much the same, okay, between these two groups. The other thing that they give you is your confidence interval. And they don't state it, but it looks like a 95% confidence interval. And they're saying that that is 0.249 to 1.389. And basically, you stick a little mu in the middle there for your mean value. And the confidence interval is just telling you the range of values it's likely to contain, the population value, how many of the data will fall into this group. So basically in this case, it's saying 95% of the data will fall in between decimal 249 and 1.389 on your chart. That's the number of standard deviations. And so it's telling you that 95% of your data will fall in this range. And so you're, again, relatively confident that because t-crit at 1.98 is our upper bound for what defines abnormal or critical region, that we are well within the critical region with that confidence interval. So all of this information is quite related and slightly different as you're working through it. But from what I can see here, they just want you to read through all this information and show that you understand what it tells you, and how you can take the results from these tests and decide whether to accept or reject your null hypothesis.